This video is going to have a couple of circular motion questions. The first one is from the 2009 examination. This is a very standard sort of question. We have a trolley going down into a loop, and we have to find the speed that it has to go at so that it just doesn't leave the tracks. So that we want the speed at point A, so at this point here, where the trolley can go around there without leaving the tracks, but without having any normal force pushing it down there. So at that point, we need to have the sum of our forces being equal to a centripetal force, which is going to be equal to mv squared on r. Now, if it's to just go around without leaving the tracks, then the normal force has to be equal to 0. That's because as it goes around, all of the centripetal force that's going to be supplied is going to be from the weight force, and there's going to be no normal force pushing down and supplying any extra force to keep it going around the loop. So our weight force, which is equal to mass times gravity, has to equal the centripetal force, mv squared over r. Here we can cancel out our masses, which just leaves us with g equals v squared on r. We want to find the velocity, so rearranging, we're going to get v squared is equal to g times r, and we're going to take the square root of that to get square root of gr. Because we want the speed, we just need the magnitude, we don't have to worry about a direction. Putting our values in, we get v equals the square root of 7 times 9.8, which gives us an answer of approximately 8.3 meters per second. And that would be to the right, but because we need the speed, we just need our magnitude. This second question, we have a racing car. It has a mass of 700 kilograms, traveling around a corner at a constant speed. The car's path forms a circle of radius 50 meters, and the track is horizontal, so we don't have to deal with any banked forces. And the central force, that is the centripetal force, provided by the friction between the tires and the ground, is 11,200. So first question, we need to find the speed of the car. We know the mass is 700, we know the radius is 50, and we know this force, the centripetal force, is 11,200 newtons. Using the formula for centripetal force, we know that's equal to mv squared over r. Putting in the values, we're going to 11,200 is equal to 700 times v squared over 50. Rearranging, you're going to get v squared equals 800, so therefore v is equal to 28.3 meters per second. Second part of the question, we need to find the acceleration of the car. All the other things are the same. Now there are two ways we can do this. We can first use F equals ma. Rearranging, we get the acceleration is equal to the force divided by the mass. Putting in our values, we get 11,200 divided by the mass, which is 700, which gives us an acceleration of 16 meters per second. Second way, we can use acceleration is equal to v squared over r, so our centripetal acceleration formula. Before we got v squared is equal to 800, so we have 800 divided by the radius of our track, which is 50, which again gives us 16 meters per second squared. Both answers are fine, both answers would get you full marks in an exam. These types of questions are very, very common. You are always going to get a centripetal acceleration or centripetal force type question in an exam, because circular motion is a big part of the motion section. So these are the types of questions that you need to practice.